So in this video I'm going to take a look at an open differential. They are a small automotive differential. I just kind of want to go over a few of the procedures just to clarify and understand what they are and what they're doing and the reason we do them in a specific order. I'm also going to take the differential apart so that we can look at some of the different pieces and identify them correctly and look at how or what exactly they do. So looking at this differential, this is an open differential. I just want to talk about it. Open differential means that there is no lockup function to this differential if there is nothing to aid in that vehicle getting out if one wheel has lost its traction. The other thing we would look at this is the normal way that this differential is going to sit in the vehicle. We have a lower pinion gear, which we refer than what the center of the crown gear is. When we get them apart, we'll demonstrate that again. But it means that this is a hypoid style differential as well, because the pinion gear is going to be located lower than the center line of the ring gear or the crown gear. And I'm going to probably flip back and forth with those terms a few times over the course of the video. All right. So with this, this is a differential out of a banjo style fitting, which means that when we unbolt the flange, that the whole carrier will come out of the differential, and it basically is supposed to look like a banjo. So there's nothing left on the inside. All right. I'm going to take it apart and we'll look at some of the gears and label them, and then we'll identify everything. First of all, we have two locks which are designed to hold the adjusting nuts in position. And it's a little difficult because I have this rolling around on the bench, so bear with me if it gets a little noisy because we're rolling on tin. So there's my two locks are out. Now we've made up a little pin adapter to go in here so that we can loosen off the side nuts. Now, because we're taking it apart and then going to put it back together, doesn't really matter how much we do this. All right, so those two nuts are loose. These two side nuts are loose. All right, you can see they're easily moved. Those two sides we're going to use later to adjust the tension on the bearing and to move the tooth contact pattern. Next, we're going to remove the two caps. Now, for the caps, once you have the bolts out of them, all right, and I'm going to tell you that these are well labeled and marked because of the number of times they have come apart. But if you were working in a normal situation, you would want to make sure you identify each one for the particular side. When you look on, there's my adjusting nut. All right, and we have a very fine thread on the inside of this cap, which is going to be mated to the thread on the inside of the rest of the housing. We're going to go just ahead and just take that, let that all fall away. We'll keep the sides separate, and then we'll have a look at the rest of it. So on the inside here, you can see the pinion gear. All right, and this is in its normal orientation. So we have a spiral bevel gear that is going to match into this spiral bevel gear here as well. All right, I'm not going to bother to remove the pinion because we use a collapsible collar in here. If I was to remove it and replace it every time, we would wear it out very quickly, and there's no real point, nothing really to see in there. All right, so I'm going to flip this over. You can see on the top side of this is the whole carrier assembly, right? And in here we have our our pinion gears and our side gears, and we'll identify them when we get them apart. These side gears, there's going to be two of them here, one on, of course, each side. This is where your axles are going to come in, and your axles are going to drive through this hole and be splined into each side gear. All right, so now with the bolts out of the back of the crown, I have given it a couple of little taps and the crown has fallen off. That'll let us see everything that's in here on the side. So here's the entire carrier assembly. I'm going to try and do it with this because it makes everything out of the way and it's nice and easy to see the two gears. When we are driving straight forward, this is rotating as one piece with my crown gear. When an axle starts to speed up because it's going around a corner or for whatever reason it has lost traction, that gear will actually start to accelerate, and through the two straight bevel gears of the pinion gears, it will transfer that speed change to the side gear on the opposite side. Now, I often hear on videos where people refer to that as, well, when this one starts to accelerate, the other one turns backwards. That's not the case. When this one starts to accelerate, the other one is still rotating in the same direction, but it is changing its speed. And the speed change is equal from one side to the other. If this one slows down 10 revolutions per minute, this one will speed up 10 revolutions per minute. And we do that because all of these gears are in contact, and what we're doing is transferring the change in speed through all of the gears. All right? Now, these are straight bevel gears, which means that they're designed to create a power flow at 90 degrees, and they are a fairly coarse tooth contact. All right? Now, this is a light-duty one. It makes it nice and easy to see because we have things out of the way. But in heavier duty differentials, what you may find, instead of a pinion shaft in here holding the pinion gears on the end, it may be a cross similar to like a universal joint, and we will have four gears. All right. The purpose of, or the advantage of having 4 gears is that I'm able to split my torque over 4 different areas, so I'm spreading the load around a little bit. So I'm going to go ahead and put the crown back on now. There's the crown gear. You can see all the bolts. When you're going to put this on, from the back side, start a couple of bolts in so that you don't get it pressed on and then be in the wrong spot. Again, so once you have all your bolts started, simply just tighten them in a pattern around the outside to try and pull that crown gear up evenly. This one is bolted. There are some of the other ones on the larger trucks or just different vehicles where they may be riveted on and require it to be reconnected, that method. So now it's come up pretty even all the way around. I'm just going to go around and secure them or tighten them down. not torquing them, but if I was installing this back into a vehicle instead of putting it back up on the shelf, I would definitely have a torque wrench and torque them all to the correct value. So they're all back tight. I've got my crown and carrier assembly all built back up again. Now we're going to start talking about making adjustments. All right, so I've got my housing mounted in the vise, and the first thing I'm going to make sure that everybody understands is they've mounted this upside down because on the bottom there is no place for the vise to actually grab the flange. It's not going to make any difference to our adjustment procedure. We're simply going to go through it. Now the biggest thing with this is understanding what each adjustment is and the fact that you have to set it to your specifications whenever you are rebuilding your differential. All right, so as I said earlier, I did not remove the pinion gear out of the front of this. All right, remember it is a crown and pinion assembly. The pinion to the crown is going to give me a change in direction of 90 degrees. Plus, because it is a small gear driving a larger gear, we are going to get a gear reduction one more time in my differential. The first procedure to check when we have set or install this is to put a inch-pound torque wrench on this and check the amount on a dial type torque wrench, because what we need to do is, without creating any drag by touching it, we need to take a reading, and I'll move the camera around so you can see the needle moving a little bit. So what you're going to notice with this dial is that I want to have a continuous rotation. The needle may jump a little bit if I stop and start, but what I want to have is a continuous rotation when I'm making my reading. Now, depending on your specifications, all right, you may have to make an adjustment on this. We would adjust it by tightening this nut. In other words, we're squeezing the two bearings in the pinion together, creating more drag on them if we need a higher number, and we want to back it off slightly if we are trying to lower it. Now, on this one with a collapsible collar, and as I said earlier, I didn't want to take it out because they're should be replaced every time you remove them. You can see that there was a slight drag on this, and I'm not going to adjust it one way or the other. We're simply going to work with it. This is referred to as pinion bearing preload, and it must be done first. When we get to the next stage, which is going to be total bearing preload, that will occur after we have added the crown and assembly into the back, all right, with the rest of the carrier. So here I am, I'm on the side. I've got my differential kind of perched up here precariously. I've got the carrier sitting in. I've got my bearing cup sitting here, and we have I've started my screw in. All right, this is where a lot of problem can occur, and people will get these cross-threaded, and there are several ways of going about doing it. Some people will try to assemble the two halves so that the threads line up beforehand. I like to actually have it so that it's fairly loose, and basically what I'm doing here is I'm just spinning the nut with my fingers, and if it turns easy enough, I'm going to assume that it's in the correct groove and not cross-threaded. If this goes well, then we're just going to repeat that process on the other side. We snug down. All right, just to check and make sure it's okay, you should be able to, by hand, make an adjustment on that screw. You're not actually going to make the adjustment, but if you can move the nut, then you know that you're not cross-threaded. So we're going to roll it around now and repeat that process on this side. There we go. Start my bolts in. Now, you want the bolts to be snug. You do not have to have them super torqued yet. You want to be able to rotate this adjusting nut to where you need it. We're just going to stick this in here and make sure it's still going to work. Yep. All right. So now we're going to go to the next thing on our setup. You can hear there's quite a bit of contact, quite a bit of movement. You can see it in there. So the first thing I have to do now is set my total bearing preload. All right, total bearing preload is going to be a combination of the preload that I had on the pinion bearing earlier, and now the extra load of trying to turn the crown gear as well. All right, now we've got quite a bit of movement back and forth here, so I'm going to start by using my adjuster and tightening in this side. Because I've got an excessive amount of backlash, I'm going to move it towards the pinion gear, and that will reduce the backlash. All right, and we can move this one in a little bit too. So, we've got it, most of the play out of there. Now the next step of this is going to be to use my dial gauge torque wrench again. I'm going to put it on the pinion, and I'm going to rotate it and check and see what the total bearing preload is next. All right. So, and as I said a minute ago, the pinion bearing preload, we set it first. But now it's a little higher because I'm also turning the crown. All right? I'm going to say it's not high enough yet. So what I'm going to do is I'm going to put a little bit more tension on each of the side bearings, and that should increase the overall tension. You don't want to make great big changes in this as you're doing. Oh, that's getting better. All right? And again, as I said earlier, keep looking and see what your specs are. All right. So now we've got a total bearing preload that is acceptable. We've got, still have some backlash in here. All right. So backlash is basically a space that is able to be between the spiral bevel gear of the crown and the spiral bevel gear of the pinion. So how we measure that is we're going to position a dial indicator on the back side, and we want to position this so that it is as close to a right angle to the teeth, to the crown tooth. Okay, so hopefully you can see the needle on the gauge. What I am doing is with one hand at the front, I am holding the pinion. And now I'm got to make a little adjustment. All right, that is measuring the backlash. What the pointer is as close as I can get it to a right angle of the side of the tooth and coming past another tooth. It should read then the total amount of movement. All right, that is too much. All right, now we have set our total bearing preload. So now, in order, I want to maintain that total bearing preload, but I have to get rid of that backlash. So what I'm going to do on this case is I'm going to look at how much I turn my nut on my right side. I'm going to back it off 2 circles. Then I'm going to go to the left side and I'm going to tighten it 2 circles. By doing that, I have moved the crown gear closer to the pinion gear, and I've removed some of the backlash. Not enough, you can still hear it. So we go back, and again with this I would say try to make small movements or small changes. Going too far at once is not going to give you a very good result. Again, 2 notches off, 2 notches on. Are we still in contact? Yes. Hold it. Still more. There, we're about 3 thou now, so that should be sufficient for the exercise to just demonstrate what it is, how things are going. There is one more inspection that we will talk about, and that is a tooth contact adjustment. We could have done this earlier, but because my crown was so far out, I wasn't going to bother attempting it. I would suggest at this point is we apply a small amount of Prussian blue on here and then do a rotation. Now when you are rotating it, it's best to have somebody apply pressure with a rag against the outside of the crown over here to create a little bit of drag. While you are putting a wrench or a socket on the front and giving it a smooth rotation in the normal direction of travel. All right? And in that pattern then you should be able to see where on the tooth it is hitting. And we could talk about that in a theory class as well then. All right? Okay, thank you.